Okay, hello, welcome back once again. My name is Victor here. We are still looking at issues around the circle and its properties. All right, look at this question here. It's also a Waec examinable question I picked from somewhere. All right, so this question, I'm trusting God that we are going to understand it too, because it gave me little, trouble for me to be able to, rectify it. And I'm going to handle it in my own way. I don't know, my colleagues out there, you may have your own proven way to handle this issue, but I'm trusting God my own is going to be very, very, elaborate. I trust God for that. So, what does the question say? This question is saying that, you see this shaded part, of course, the diagram is a semicircle. It's a small semicircle and a big semicircle. Both of them, this small one is inscribed into the inside the big one. All right. So they are saying that in the figure, the area of the shaded segments are 36 cm squared. That should be the big one, and 16 cm squared, which is a small segment of the small semicircle. They say if the diameter of the large semicircle, I guess that should be from here to here. Okay. Okay, if the diameter of that big semicircle is 39 cm, then what is the diameter of the small semicircle? It's a why question. Okay, what's the diameter of the small semicircle? I have to give it this a thought. You know, if you look at this problem, you will quickly see a smaller quantity inscribed inside a bigger quantity. And what can that convey to you? You just think talking about ratio. Ratio. What quantity of this is contained inside this other quantity? What quantity of this is contained inside this other quantity? Is ratio. It's an expression of ratio. That's my concept. That's the way I saw it. And I went through that way and I met the solution. Okay. Which I'm trusting God you understand when I put it up here. So I went through that direction. I said, if if I express the ratio of the small sector to that of the large sector, will it give me a result which will amount to ratio of the ratio of the bigger segment to that of the smaller segment? So I tried it. Okay, let's look at this. I look at what I said. I now said solution. I now said let small r be of radius of small semicircle, semicircle, okay, and capital R radius of big semicircle, semicircle. Okay. Now, in the expression of minor segment, you know that minor segment is given by area of sector minus area of triangle, which we have looked at enormously in the previous classes. Okay, so and area of a sector, which I said minus area of triangle, will give you area of the minor segment, is expressed mathematically as this: theta over 360, okay, times pi r squared. This area of a sector, but I'm using r squared here in line with the small semicircle that has a small sector. Do you get that? So this is for the small sector. And if you remove 1 over 2 r squared sine theta, this now will give you here That's area of the minor segment of the small semicircle. I am trusting God you following me. This will give you this here. Now, if I want to express this as a ratio over theta over 360 times pi, capital R now, because this belongs to the big one, R squared. This is the area of the sector of the big semicircle. This is the area. I'm using capital R now. If I remove 1 over 2 capital R squared sine theta, I have obviously obtained the value for the minor segment of the big semicircle. I trust God you get it. I trust God. This is the area of the minor segment of this small semicircle, and this is the area of the minor segment of this big semicircle. We've got it. So I can equate this now to be equal to, for the small one is 16 over the big one, which is 36. 36. This is exactly what it is. So the issue now is, how will you resolve this to get radius? Wow. How will one be able to resolve this now? And what you just need is the radius, so that you can now be able to times it by 2 and get the diameter of the small semicircle. That's what we're looking for. But I am going to show you something now. You have to accept this because it's mathematically correct. It's mathematically correct. If I say A, B over X, Y is a quantity, right? And I just choose to say this quantity, let me remove from this quantity minus sine AB, and this one, let me remove again from you minus sine X, Y. I think I didn't commit any offense. It's mathematical. What I did here is what I did here. Whatever you are, if you are 20,000, I'm taking away 10% from what you are. If you are 10,000, I am taking away 10% of your 10,000. So 10% from this person, 10% from this person. Now, let me show you something. What if I choose not to take away the 10% again and leave the 10% for them? I think they will go rejoicing. Fine, you are there. You are there. Okay. I'm going to choose not to take away, because if you watch here, is a takeaway of half R squared, which is contained here. Half R squared sine theta. Look at theta. And it is the same takeaway of half R squared sine theta. Can you see that with me now? You're there. You're there. So, in my choice, I am going to choose not to take away this from them. Let them have whatever they have. So, I didn't offend anybody. So, I am going to bring down theta over 360 pi R squared over theta over 360. Then the same pi capital R squared equals to, I didn't touch you guys again, so go home, be happy for yourselves, equals to 16 over 36. Okay, so we have it here. Don't be offended once again. We're still going to do some little, small things here. Follow me. I am wiping away this and this. Yes, I'm taking them away, so that I will have left r squared over capital R squared equals to 16 over 36. Okay, there's no problem there. I'm sure you understood that. I'm sure you understood that. So, what do we have? Now, we were told that the large semicircle, the diameter is 39 cm. And when you say diameter is 2 times radius. So, I'm going to rewrite that as r squared, which is radius of small semicircle, all over radius of big semicircle, which is 39 over 2, will give me the radius. Then now I'm squaring it, equals to 16 over 36. All right, cross multiply, cross multiply. Wow, best thing you do is to send this video to someone. Please do that for me. Do that for me. Send this video to someone, please. All right. When we cross multiply, we have 36 r squared equals to 16 in bracket 39 over 2 all squared. So we have 36 r squared equals to 39 squared. 30. I think I have figures that could help me to have that. 39 squared is 1521. 1521. So 16 times 1521 over 2 squared is 4. So this will take care of itself. Carry here, I have 4. So we will have 36 r squared equals to 4 times 1521. 36 r squared equals to 4 times 15. Okay, will give us 6084. 6084. So r squared is equals to 6084 over 36, and that is 6084 over 36 will give us 169. 169. So we have r is equals to square root of 169, and that is a 13. 13. So do you see that the radius of the small semicircle is 13 cm? So, but what they asked us is, so what is the diameter of that small semicircle? So the diameter is 2 times 13, and that will give us 26. Excuse me. That will give us 26 cm. That's how we were able to handle this. That's how we're able to handle this. I am trusting God that the explanation is taken. It's very detailed. Look at it again. Go through the video again and again. Go through my explanation again and again. Please, like I said, send this video across to someone out there, and please subscribe. Click on the subscription button, and then, because if you do, you access over hundreds of videos, classes we already have online. You access them. Yes, you can be able to access them. We have treated so many topics already, and with detailed explanation. Of course, if you watch this class and you could embrace it, you should also see the possibility that you will embrace the other classes we already have. Thank you so much for being there. Please like our video, and if you feel like supporting us in your own way, our email is down there. Thank you so much.